All right, can everyone see me now? All good? Perfect. Okay, so greetings, everyone. We are delighted to extend a warm welcome to everyone of you on our fifth webinar hosted by the AFRONE. We're glad to have you all on board and looking forward to making this a fruitful session. Before we begin today's session, as usual, the guidelines that will make to help us make the most of our meeting. The microphones and cameras will be turned off to minimize the distractions, and your interactions will be and your active participation throughout the chat is highly encouraged. Just add any questions there you need, and at the end of the session, we'll be monitoring and responding to them. The duration of the session will be 1 hour. The first 45 minutes will have the main presentation with our speaker, followed by 15 minutes for the Q&A session. And please note that the session will be recorded for future reference. We'll post it on the LinkedIn, on the WhatsApp group, and in the future on our AFRONE website, inshallah. Lastly, your feedback is valuable to us. I'll be sharing a feedback form in the end of the webinar and the chat. And on the WhatsApp group, please take a few moments to share your thoughts with us and fill the form. Now, please join me in welcoming today's speaker, Dr. Ahmed, professor and the current head of the Department of Community Dentistry at the School of Dentistry, University of Pretoria. He is the chair of the postgrad committee and a member of the research committee at the School of Dentistry at the University of Pretoria. His research interest includes cardiology, early childhood carers, dental public health, health policy, human resources, and dental education. He has published over 50 articles in peer-reviewed journals, has more than 750 citations, and he's presented at numerous conferences, both locally and internationally. He is the IADR representative for the University of Pretoria and the treasurer for the Africa Middle East region, AMER, of the IADR. Please welcome Dr. Ahmed.
Good afternoon, colleagues. How often have you heard incomplete data, too small a sample size, missing or poor controls, inappropriate methodology for answering your hypothesis, inaccurate conclusions on assumptions that are not supported by your data? Many of you might be junior researchers, but the more senior researchers most probably have heard this over and over again when you submitted your paper to a journal for publication and it got rejected, right? Okay, so today we're going to discuss how we can prevent these emails from entering into your inbox, because obviously part of our presentation is to get you to publish. And we want you to publish, and we don't want to see these emails in our inbox. So my name is Ahmed Bhayat. I'm a researcher in South Africa. I hope you can understand my accent. I've got a bit of an Indian accent, an African accent, a British accent, a bit of an Arabian accent. But I hope that you can all hear what I'm saying. And if you have any problems at the end, we just put it into the chat box, or you can just ask me and we can try and address it. So what are we going to do today? We're going to look at sampling. I'm going to give you an introduction into sampling techniques. We're going to define sampling. We're going to look at the different sampling types that we have. I don't want to make it too theoretical, because at the end of the day, I want you to be able to apply these techniques to your own research that you are doing. So I'm going to try and keep it very example friendly, very application friendly, rather than very theoretical. But if you want theory, we can do theory at a later stage. We can look at some sampling difficulties as well. What do we need to look at when we are doing a sampling system? How do we make sure that we've ticked all the boxes? And then some statistical considerations. I hope I can do justice to the statistical part. Statistics is a huge chunk, and I don't think I'll do justice in the limited time that I have, but let's see how far we go. And if we need to expand it, we could do it at a later stage, if everyone's okay with it. So our research protocol. Over the past few weeks, we've had very interesting discussions from very well-renowned speakers from over the continent and even from other continents, where we looked at how to write up a research protocol, what defines a research protocol, what kind of ethics we need to look at, what kind of funding we need to look at, what type of study designs we need to have. So today we're going to look at the sampling. And I've put on this slide because for my students, I always tell them that the methodology is the most important part of your research protocol. That is the engine. That is what drives the research. If you have a strong engine, whether it be a bus, like a PhD, where you're going slowly with lots of data, whether it be a helicopter, like a pilot study, whether it be an aeroplane where you're going fast and quick, you all need an engine. So if your engine is not strong, if you don't have a strong methodology, chances are you're going to get those emails in your inbox when you submit your paper for publication. I also took note last week when some of the students were saying the differences between the different type of study designs. For me, as a supervisor, as a mentor, I would suggest that you start first with looking at what is the question that you want to achieve. What do you want to achieve from your research? Once you get the research question and you got your aims and your objectives, then you can look at the methodology. Then you look at the study design. Then your supervisor or your mentor will guide you as to what type of study design will best answer the question that you have created. You don't look at the methodology first and then try and fill out your hypothesis. First, try and identify what do you want to achieve? What do you want to find out? You want to find out the levels of stress between dental students? You want to find out the caries prevalence of dental care of crash children? What do you want to find out? Once you have that clear, write it down on a page, write it down a few times, read it, try and identify how you will achieve it. And then with your supervisor, you then look at the methodology and the design that will best suit to answer that question. If you use the wrong methodology, if you use the wrong study design, you will not be able to answer your question. If you don't have the right sample, you will not be able to answer your question either. So once you have your methodology, once you have your study design clear, then we can now look at sampling, because sampling is very dependent on the study design and dependent on your hypothesis and on your question. So, will you marry me? No, you haven't lost me. I'm still here. I'm sure many of you have heard that question before, or many of you are still waiting for that question. I'm asking the females. No, I'm joking. I'm not asking anybody. I often tell my students sampling is like a marriage proposal. When you choose your partner, you have certain criteria that you need your partner to have. Either I'm talking from a male perspective. Please don't, I'm not sexist. I'm just talking from a male perspective. For example, you'd want your partner to be honest. You'd want it to be loyal. You'd want it to be strong. You'd want it to be beautiful. These are the criteria that you want. When you find someone, and believe me, we've been there, when you find someone, you might not tick all those boxes, but there are some criteria which you will not buy into and some criteria which you could afford to let go. I mean, beauty, maybe we could let go, but integrity, honesty, loyalty, those are criteria that you will not let go of. Similarly, when you're choosing your sample needs to address the criteria that you want to achieve. If you want to find crash children who have caries, you need to find in your sample crash children who have caries. You cannot go to the hospital and find crash children in the hospital because that population is very different from crash children who are attending in the school. So you need to be sure what your objective is, what are the criteria, and will your sample represent the population from which you are getting your patients, or your let's call them patients for our purposes, your patients. Many a times we don't have the time or the resources to involve the entire population. Many of you are doing your masters, some of you may be doing a PhD. We have limited resources, we have limited time. We want to finish the research and publish, and we want to get our degree, and we want to move on. So when you're choosing a population, you need to see, is this population attainable? Can you get to this population in some way? How will you attain this population? If you want to study people in the South Pole, how will you get to the South Pole? How will you get there to find Eskimos? It's not going to be practical, but you need to understand what do you want to find out and where will you find these people, okay? So if you move on, the big question they will always ask a supervisor, how many do I need? How much is enough? And that's purely relevant. It depends on your study design. It depends on your study purpose. What do you want to achieve? It even depends on the disease burden. If you have a disease that is highly prevalent versus a disease that is not so prevalent, your sample size would definitely change. So this is purely relevant. No statistician is going to tell you that you need an X amount of patients or an X amount of samples for your study to occur. But you need to look at it in the context of your study population, of your study design, of your methods, of your disease burden. And in that way, you then work out what is the minimum sample size that you require. So when we're looking at, I said patient, but the element could be a document. It could be records. You want to do an audit of the patient records that have come to your facility. You want to find out how many patients attended for dental extractions. You're going to do a retrospective record-based study. The sample then becomes records. It could be blood groups. It could be height. It could be weight. It could be BMI. It could be socioeconomic status. All of these could be the criteria that you need to use. And you need to be sure of you being able to attain these kind of criteria in your population. Otherwise, you're going to be wasting your time trying to fill a population where you're not going to achieve anything. So study design, I know we've covered this previously in one of the previous discussions, and I just want to give you a quick snapshot of how study designs impact on sampling. By and large, the biggest differentiation between study designs is qualitative or quali and quanti. In our terms, we abbreviate everything. We say quali and quanti. Quali is your focus groups, very small samples, maybe 8, maybe 10 people in the focus group. That's enough. You might have 2 or 3 or 4 focus groups, but very small, very intense, very emotional, very personal, very in-depth. That's qualitative study design. I'm assuming many of you, I'm not sure what level you're on, but when we start off with our postgrad, we would tell them to rather start off with a quanti study first and get some experience in research. And then if they want, they could do a quali or they do a mixed, and we support them with doing the mixed, because quali is a bit more complicated when it comes to the analysis, but we'll get there at one point. So quanti takes a lot bigger sample size or more numbers compared to quali. And if you look at the breakdown, if you look at the slide, you would see that you have 2 differentiations in quanti. You have observational and intervention. Observation means I'm just going to observe. I want to find out how many students smoke in the dental campus. So I'm just going to observe. I'm going to have a questionnaire. I'm going to give out the questionnaire. Everybody who answer the questionnaire will tell me yes or no, I smoke or I don't smoke. I'm going to observe. Do I want to compare? Do I want to compare dental students to maybe medical students to maybe pharmacy students? Then I put in a comparison. So then my sample size now has to get bigger, because I need a certain amount of dental and I need a certain amount of pharmacy or medicine or whatever else. So my sample size is already increasing. If I do descriptive, that means I'm just going to describe. I'm going to say males smoke more than females, dental students smoke less than pharmacy students. That's my description. CS means cross-sectional. I'm going to look at it once off, cross-section. If I do a cohort study or a case control study, I need more patients. I need a longer time. I need more samples, because I'm going to follow them up over a period in time. And this will impact on the number of samples that I would need. If I do an intervention study, non-random or randomized controlled trials, I would need large numbers of samples, because one group would get the placebo, one group would get the gold standard, one group would get the intervention, and I need sufficient numbers in each arm so that when I do my statistics, when I run my stats, I can make sure that I can get decent answers so that I can make comparative, or I can make strong, robust conclusions and way forward for that. I hope I'm not going too fast. No comments, so I'm assuming it's good. Okay, one of the key elements of sampling is representativeness. When you choose your sample, you have to be sure that it represents the population that you are looking at. So if you look at the small little sketch on the left-hand side of your slide, you'll see there are 4 trees. You want 1 tree. You only have enough time and enough money to work on 1 tree. And you draw up your own tree that looks like the one at the bottom. That is not representative of any of those 4 trees. The results that you get out of that study, most probably the journal is going to tell you the same thing. Your results are not representative of the audience that we are responding to. So what's happening is you're wasting your time, because you are trying to make the 4 trees look into one, and this one does not represent any one of them. So when you choose your sample, it has to be representative of the population from which you are drawing them. If there are more females, you need more females in your sample. If there are more males, you need more males. We'll discuss how we're going to stratify at a later stage. But for now, it should replicate the population in every perspective: age, gender, race, socioeconomic status, education. You cannot say that I'm going to do a sample of people living in informal settlements or in slums, and then take your sample from a very affluent area and include just a handful of people living in your slums. That will not be representative of people living in the slums, because the proportion of the population does not represent the proportion of the people that you want. Okay. Yeah, sample size calculation. So we're going to get to sample size calculation a little later on, and the factors that impact on the sample size. So like I said, we will do some theory. This is the theory part, and I hope this is not too boring. But in terms of sampling, we get 2 basic concepts. You get your random or your probability sampling and your non-random, non-probability sampling. Together with your supervisor, you will decide which is the best for your study, which will answer the questions most accurately, and which will be generalizable for the results that you want to achieve. So random sampling is further subdivided into simple random sampling, systematic sampling, stratified sampling, and cluster sampling. For some of you, this might be very boring. I'm sorry. For some of you, it might be completely foreign. I'm also sorry, because I'm not sure where to pitch this. But I'm going to take you by your hand, and we're going to go from the beginning till the end. And hopefully by the end of the presentation, you would have an idea of where we are. Non-random means that everybody does not have an equal chance of being selected. Okay, and you have three different types: convenience, snowball sampling, quota sampling. These are just overall, these are an overview of the sampling concepts. But when you sit down with your research, with your supervisor, with your mentor, you must choose the most appropriate for your study design. There's no right or wrong. Yes, there are strong sampling techniques and weaker sampling techniques, or more robust and less robust. But at the end of the day, it depends on what you want to examine, what you want to find out. If you cannot find, if you need some, if your study design is on a disease that is very, very rare, you only have 2 people per 100,000 who have this disease, the sampling cannot be simple random sampling, although that might be the most robust. But at the end of the day, you need to look at the condition that you are looking at and which would be the most suitable for you to obtain the information. So let's go through each one. Okay, simple random sampling. I don't know if any of you have seen this. In South Africa, we have this thing called the lotto, where people gamble, not gamble, gamble. They tick numbers every week, and every weekend they have this on the national TV where they would rotate a ball, and all these small little balls will pop out at the bottom. And if you meet up with those 6 numbers, you become an instant millionaire. And if not, well, you try again next week, and the process goes all over again. So simple random sampling means that everybody in your population has an equal chance of being selected. It's like these balls in this Ferris wheel. Every ball that's in there has an equal chance of being accepted. There's no bias. Whether you're pink or yellow or blue or green, at the end of the day, you have an equal chance of falling out of that hole and getting selected. So this is called simple random sampling. The biggest problem or the biggest issue with simple random sampling, you need to know your denominator. You need to know how many people are in your population before you can randomly select. So if, for example, you want to look at students in the dental class and find out how many of them have, how many of them smoke. Let's do smoking. How many of them smoke? You have a class list of all the students. That is your denominator. So you know exactly there are 50 students in this class. Then you can randomly choose 10, you can randomly choose 20, you can randomly choose 30, whatever you want to choose, but you have a denominator. You sit with the list and you can choose student numbers or names from that list randomly. If I don't know how many students are in the class, I cannot choose simple random sampling. If, for example, I want to go into an informal settlement and I want to find out in the slum area how many people smoke, I don't know how many people live in the area. How will I get the denominator? How will I know what number to draw from? So I cannot use simple random sampling if I do not know my denominator. If I go into, for example, a school or another school, if I go into a clinic, I want to find out how the patients perceive the cleanliness of that hospital. When I go in the morning, I don't know how many people are going to come during the day. I have no clue because every day different people are going to come. I can look at the register and I can assume that 50 people will walk in through the door, but I don't know for the fact how many. So I cannot use simple random sampling. I need to use another technique that will address the questions that I might be having. Okay, random sampling, we said there are 4 different types. So systematic random sampling and stratified are 2 other types of random sampling. Again, random meaning everybody has an equal chance. But systematic random sampling means that, say, for example, I want to do an audit of my facility, and I know that on average, 50 patients come in. I only need 10 patients, though. I only need 10 patients. I only have money and time for 10 patients. So what I would do, I would say every 5th patient that walks in through the door, I will give them the questionnaire. So that's systematic random sampling because I know there's 50 on average that are going to walk in. If I do every 5th, I will get 10 patients at the end of the day. That would be my sample. That would be a simple random, systematic random sampling. Everybody had an equal chance of coming. It just depended on what time you got up this morning and what time you drove to our facility and what time you walked through the door. You were either in or you were out. Okay, so systematic random sampling. This is often used where you don't know the number of patients that are coming in. Like a hospital, like an informal settlement or a slum, where you sit at the entrance and you say every 5th person walking into the slum, I will give them the questionnaire, or every 5th person walking into this area, I will give them a survey. That is systematic random sampling. We move on to stratified. Stratified, as the name suggests, we are going to divide the population into strata or divisions. Let's call it divisions for ease of word. So for example, if we have, let's say we still have the 50 dental students, I want to know how many of these dental students smoke. But I know from experience and from the literature that males tend to smoke more than females. For example, I'm just giving you an example. In my class of 50, I've got 40 males and only 10 females. If I do random sampling, chances are I will exclude all the females because I only want 10, but I've got 40 males. My chances of getting 10, I will get a lot of males. So I divide or I separate them into males and females. They've got 10 females, 40 males, right? So I divide them up. Remember, I can only take 10. I'll take from those 10 females, I will randomly select 5 females. So I've got 5 females. And from the 40 males, I will randomly select 5 males. Then I will have 10 people. They will represent males and they will represent females because I'll have both males and females in my sample. So I can divide my population according to strata. I can divide it according to gender. I can divide it according to race. I can divide it according to socioeconomics. Whatever you tell me, I can divide it. I need to know what my criteria are. I need to know what my variables are, and I need to know what would be confounders. So if, for example, I know that there's a gender prevalence in a certain condition and I need both genders, then I need to be sure that my population will have equal or a relevant number of both genders. I hope you guys are still there. Okay, still random sampling. The last type is cluster random sampling. Cluster random sampling, as the name suggests, it's clusters. So we often use this type of sampling when we want to do a national oral health survey. Or national health survey. I'm saying oral health. I'm assuming we're all oral health personnel, but let's say oral health survey. If I want to do an oral health survey in my country, in South Africa, it's huge. We've got 9 provinces. How will I obtain information that represents my country? I cannot go to one part of the country and say this represents the whole of South Africa. And often we see that when we're reviewing a paper or when we're reviewing a protocol, where the title would say carries prevalence in South Africa, but they would only use one province. You cannot generalize one province to the entire population of South Africa. So be careful when you are drawing up your objectives and your aims to align it with your title, to align it with your methodology. You need to be sure that if you're saying South Africa, then you are representing South Africa. Okay, so let's go back to cluster. So in cluster random sampling, it's multi-stage random sampling. So for example, I'm speaking for South Africa, and you guys can use this for your own countries. We have 9 provinces. So I will divide my population into the 9 provinces first. Within each province, I know that there are maybe 5 or 6 districts. Within each province, I will divide it up into the 6 districts, and I will randomly choose maybe 2 or 3 districts. Now that I've got districts in each province, I can then go into those districts and I can further cluster them into, let's say, high socioeconomic districts, low socioeconomic districts. From there, I can then choose different clusters. So what happens is at the end of the day, I will get a very fair or a very robust population that represents the entire country because I've used geographical differentiation. If you look at this table at the bottom or the figure at the bottom, you could see that we have 15 people and we could code them as red, green, cross, circle, and a line. If I say I want every 3rd person, that will be number 3, number 6, number 9. You can see they all have the blue line. That is called systematic sampling. Remember, we said every 3rd, every 4th, every 5th. Cluster sampling. I would take 1, 2, 3, make it a cluster. I would take 4, 5, 6, make it into a cluster. 7, 8, 9, make it into a cluster. So what happens in each cluster, I've now got all 3 of these people. Then I can randomly select maybe 2 clusters of all of these clusters because I don't have enough money or enough time. I don't have time for all of them. I just randomly choose 2 clusters, knowing confidently that each cluster has one of each of these different kinds of variables. Are we still here? Yeah. No feedback.
Oh, good.
Okay, good. So now we go to non-random sampling. Non-random sampling, like the name suggests, everybody doesn't have an equal opportunity of being selected. It's not like the ball where everybody is in this ball and any ball can drop and anybody can be selected. It's not like where I have a class list and I can randomly choose people. It's not like where I have a list of crashed children and I can randomly choose. Now I don't know my sample. I don't know my denominator. I don't know how many people are going to come in. So this is not as robust as random sampling, but in some instances, this is the only sampling we can use. So it's not to say that we cannot use others, but we need to just justify why we are using specific random or non-random sampling techniques. So non-random sampling is often chosen by the researcher on specific criteria. So for example, convenience sampling, you want to go to a crash or you want to go to a school because you know the people, you know how to get there, you know what to do, you know people who will allow you to take the data. That is convenience sampling. You're just choosing a venue or you're choosing a site or you're choosing a sample because of your association with them, because of your geographic location with them, because it's easy. Let's call it easy. Yeah, this is not a very strong form of sampling because obviously it's biased. If I like a specific school or if I like a specific university and I only use that university, it is not representative of the entire number of universities in my country or in my province. So it's convenient sampling. Quota sampling is where you will choose convenient sampling, but then you would stratify. So again, I would choose the different schools or the different universities, and I would then divide them up according to gender, according to race, according to ethnicity, according to socioeconomic status, whatever criteria I might have. Purpose of sampling, again, usually often used in qualitative. Most of these are used in qualitatives as well, but purpose of is very often used in qualitative, where you would purposely choose individuals or subjects that you feel would meet your requirement. So for example, you want to look at a very rare condition. You will then go to a clinic ward or you'll go to the hospital and you would find patients with this rare condition and you would only include them into your sample because those are the patients that have the condition that you need. So you looked out for these patients. Or you go into a school and you find that kids that have lots of dental caries are not performing very well. Their marks in the school is very low, and you want to assume maybe there's something going on here between the marks and the dental caries. How do you stratify? How do you get your sample? If you just go in blank and you don't know the disease burden, you don't know how many kids have caries, you don't know the marks, it becomes a problem. So then you purpose of sample, you go and you look for patients who have high marks, and then you look at the dental caries. Or you look for patients who have high caries, and you go and look at the marks, and then you see if there's a correlation. That's purpose of sample. The last one, as the name suggests, is snowball. Snowball, I'm sure you're aware, it's a small little snowball that starts on the top of a mountain, and as it rolls down towards the bottom of the base of the mountain, it gets bigger and bigger as it absorbs more and more and more snow onto it. Similarly with snowball, again, used in very rare conditions. So say, for example, you're trying to identify a very rare condition and you don't know where to find people. So you eventually find one or two patients who have these cases or this condition, and then you ask these patients, listen, do you know someone else in your family, in your friends, with your colleagues who have the similar circumstances or the similar condition or the similar disease? And more often than not, they would know someone that has a similar condition. And then you would go to that person and you would recruit that person and ask that person, do you know someone who has similar conditions? And that would take you to another two people. And in this way, as you move on, you try and increase your sample size until your snowball gets bigger and bigger and until you then can get a sufficient sample size in number. Okay, so let's move on. So we spoke about the different types of sampling. We know that you get two main types, random and non-random, and we spoke about the different types within each category. We also touched on the fact that the factors that influence the sample size will be determined by your methodology. Often your methodology, your study design, the type of study you want to do will impact or will influence the sample size that you will eventually obtain. So what are the factors that you need to look out? And this supervisor or your mentor will be able to sit with you and you'll be able to discuss that because it's very, very subjective. Okay, so your study design, if it's a qualitative or a quantitative, if it's a qualitative, you need fewer subjects. If it's a quantitative, like we said, we need a lot more because it's more statistically involved. It has a lot more tests that you want to run. It's not so much in terms of themes. It's not so much in terms of focus groups. It's more in terms of numbers. So you need a bigger study size. Analysis, what type of analysis do you want to do? What type of groups do you want to have? If you have 5 different groups, you've got, let's say you've got ages between 5 and 10, you've got 11 to 15, you've got 16 to 20, 21 to 25, and over 26. That's 5 different categories. You need sufficient numbers in each category. You cannot just say, I'm going to collect 10 patients. What if they all fit into the same category? How would you look at your other categories? So you need to be sure when you're collecting data, you need to start ticking. Have I met this criteria? Do I have 10 in each category? And that will determine your statistical analysis. Finance. I mean, this is the key, especially in developing countries, especially, I would say South Africa, but I assume it goes across Africa. We do not have the materials, we do not have the tests, we do not have the blood kits, we do not have the saliva kits, we do not have whatever, the toothpaste and the toothbrushes, or even the human resources to include large samples. So often our sample size is determined by cost. If you want to do a very expensive test and you don't have money to buy the kits, you can only do so many because you only have enough money to buy certain kits, but you need to justify that will this number represent the number that you are or the population that you are looking at. If it's not, then rather wait and get more money somewhere and then start again, because at the end of the day, your results need to be generalizable. Look, we need to publish. Let's be honest. We're doing research. Yes, the research needs to be practical. It needs to impact on people's lives. I always tell the students, we don't want to do research that's going to sit in a bookshelf and collect dust. the research needs to be real. It needs to be practical. It needs to change people's attitudes. It needs to change people's lives. It needs to be working. So if you want to do research like that and you want to publish, because as academics, we need to publish, right? So if you want to do the research and publish, you need to think from the beginning, would this study be publishable? Would I be able to publish it into a journal? Would authors in other journals be willing to review this paper? Does it make sense? If I've got a small sample size of 5, often the journal is going to come back to you and say, but this does not represent the audience that we are reading, or the audience that are reading our journal. Or this does not go to a local journal because your results are limited to a local environment. And in that way, you're not going to get published. So you need to look at the finances. Don't go for a study that's extremely expensive and you don't have the money. You're going to delay your process. You're going to delay your own time, because at the end of the day, you have time to finish your research and you will not finish it in time, and your degree might not be there and you might not get publication out of it. Okay. Attrition rate. What is attrition rate? If you're following up people over a long period of time, let's say, for example, you want to see the impact that toothbrushing, or let's say you want to see the impact of oral health education on toothbrushing practices. So in the beginning, you'll do a plaque score, you'll check their score, you'll see how much of plaque they have, you'll see how much of, they look at the oral hygiene status, you look at the bleeding, you look at the gum status. You then teach them how to brush their teeth, and you tell them to come back after 6 months. When they come back after 6 months, you'll measure the same indices again. Attrition rate is how many people will come back. Remember, people don't have time to come back for your study. People have their own lives. You are doing the research, you need to bring them back. You start off with 5, if you're lucky, you'll get 2. So if you need, at the end of the day, you need enough people for your statistics. You need 10. You cannot start off with 10. You need to start off with 50. So at the end, at least you will get more than 10. If you get less than 10, what are you going to do? You can't wait for another 6 months and start a new group and give them new oral health education and wait and follow them up. So you need to have attrition rate already calculated into your sample size. And usually, at least with our students, we say at least 50% or more of the initial sample size that you would need. If I need 10, at the end, I need at least 15 to start off with. But we would rather even go higher, depending on the type of condition, depending on the disease profile, depending on the test, depending on the money, all of those issues. Accuracy, how accurate do you want your results to be? Smaller sample size, not accurate. A larger sample size, obviously, it's more accurate because it represents more people. The more people you represent, the more accurate will be your result. Size of the population. If it's a big population, you've got millions and millions of people. Again, what do you want to achieve? Will you be able to screen everybody? No. So the bigger the population, you need a smaller sample size. If it's a very small population, you can go big, but depends on your resources, depends on the cost, depends on what you want to measure. Homogeneity versus heterogeneity. Okay, this is very, very important. You might get a sample where people are very, very similar. So let's say, for example, you want to go to dental students and you want to find out from these dental students, how many of them are smokers. Generally, a group of, say, first year or let's say third year dental students at any university is very homogeneous. They tend to kind of have the same level of education because they've come from school, they've been 3 years at university. They have a similar level of socioeconomic status. They have a similar level of let's say, education in terms of oral health and smoking. So that population is very homogeneous. So you don't need many people to represent them. But if you have a population, let's say, for example, of medical students, of dental students, and of pharmacy students, and they're very heterogeneous. You've got first year students, you've got final year students, you've got fourth year students, you get different years. Suddenly now, the students are very, very different in terms of their education, in terms of their socioeconomic status, in terms of their residence, in terms of their diet. So they become very heterogeneous. So then you need more people so that you can represent all these different samples groups. Time waits for no man. If you don't have time, you cannot have a big sample. How long are you going to wait for your sample to respond? We've had the study, we're ongoing. We just completed the study now where we looked at dentists' views on COVID. Yeah, it sounds very outdated, but when we started, it was the flavor of the month because we started when COVID vaccines were being administered. The poor student tried to got the questionnaire. We went through all the loops, all the processes, and then we started sending out the questionnaire to the dentist. We needed a sample size calculation, I think, of let's just work on 200. And after 6 months, we still didn't get 200. And now we reached a point where the student needed to graduate and the student needed to hand in the thesis, but we could not make 200. And we tried, we begged, we borrowed, but people didn't want to respond. At the end of the day, we had to put it as a limitation to say that these results do not represent the general dentist in South Africa because we did not reach the sample size. So be careful of how much time you have and how much time you would need in order to get the sample size. Prevalence. If a condition is very prevalent, you've got lots of dental caries, you don't need a very big sample size because chances are if you choose a small sample size, you will get kids with caries. If you have a very rare condition, let's say a brain tumor that is very, very rare that people don't even know exists, if you have a small sample size, you're not going to pick up anything because it's so rare. But if you have a huge sample size, chances are you'll pick up a very rare condition. Okay, so what are some of the difficulties when you do sampling? I'm just going to have a quick water break. Okay, one of the issues is non-respondents, and I spoke about this with one of my students where students just did not want to respond. Dentists did not want to respond. Those that do respond often have a bias. So let's say, for example, you want to find out about something that is very, very, very taboo. You want to find out from the dental students if they take drugs. Yeah, they take drugs, cocaine, heroin, weed, whatever you guys call it. You know what I'm talking about. That's something that students will not want to answer to because they know the legal implications. They know they might be excluded from the dental profession. They know there are serious consequences if they admit that they are doing some of these things. So as a result, if you say, look, I want to ask you questions on whether you take drugs, chances are those that are taking drugs will shy away and say, no, thank you, I don't want to be part of your study. Whereas those who are not taking drugs have no problem. They have no issues. They will say, yes, I will be part of your study. This is a bias that will incur because of non-respondents where they either voluntary or indirectly involuntary participate, and it affects their generalizability. Attrition, we spoke about it. Especially if you're following up a group of people over time, you need to start off with a huge number so that at the end of the day, you will still meet the minimum number that you need. Response acquiescence. This is where people will respond in a way that they expect you to respond. So let's say, for example, you ask them, do you smoke? Everybody in this day and age knows that smoking is unhealthy. You can't tell me that someone doesn't know smoking is unhealthy, right? Everybody knows. All our countries across Africa, we have policies to reduce smoking. But as the person knows that you're going to be, he's going to be looked at in a negative light. Instead of saying, yes, I smoke, he will lie and he says, no, I don't smoke. Just so that you're not unhappy and just so that he's happy and there's no problem. So that means they will respond in a specific way in which they expect you to respond, in which they expect you to, the correct answer to be. That's also very important. So to prevent this, you need anonymity. You need to be sure that there is complete and 100% anonymity. So people are confident to respond in a way in which they will respond without any issues of being labeled or without any issues of being identified. The minute the person feels they can be identified, or the minute the person feels that there is not anonymity, chances are they will respond in the way in which you want them to respond, or they will not complete your questionnaire. And that leads me to the next bullet, which is incomplete surveys. And we have this all the time, where we would have a student collecting the data, and you come happily singing along. I've met my criteria. I've met my sample size. I'm now starting to analyze. Well and good, excellent. Let's do it. When they start analyzing the data, they realize that 10% of the questionnaires were not completed. Now they haven't met the minimum requirement in terms of the sample size. What do we do now? So always, as you're collecting data, you need to be checking. You need to be making sure that the data is complete and comprehensive so that when you're ticking your numbers, you know that you've got sufficient numbers. You don't want to stop, then suddenly go back and start looking for patients again because suddenly you realize your sample size was not adequate. So one of the tips that we will give you, or I will give you, or we give our students, is constantly analyze your data as you get it. Don't leave it and say, when I get my sample size after 200, then I will start analyzing it. As you get it, you start analyzing it, start leaning, start cleaning it, start looking for gaps, start looking and seeing whether it's going to meet the requirement. Check if one question is constantly not being answered. Then you need to look at your question and say you didn't do a pilot study and you just developed a questionnaire and you went out. But if you're not cleaning your data or analyzing it, you will not pick up that there's a problem with one specific question. But if you do that, you'll pick it up and you can modify it within limits, of course, depending on your ethics and depending on the type of survey. You can modify it, you can clarify it, and you can continue. And in that way, you will prevent incomplete surveys being sent back to you. Okay, so checklist. What do we do? Again, this we send out to our students and we tell our students to please tick it off as they're going along with the study because this is very important. When you choose your sample, is it population accessible? Is that population accessible? Can you reach them? We thought it'd be easy for us to get dentists to apply, to comply and answer the questions. I think dentists are the worst study samples you can get because these dentists refused. Yeah. So is the target population accessible? What type of sampling are you planning to use? Random or non-random? Which is the best method for your study? It might not be the best method overall, but which is the best method for your study design that you're planning to do? How am I doing for time? Okay, I don't have much time left, so I'm going to go a bit quicker. Like I said, I'm not going to do the statistics. I'm sorry, but maybe some other time we'll do the statistics. Does the type of sample fit with the objective? Again, link your objective, your titles, your aims to the sampling and to the study design. If it's non-probability, you need to just show us how you will ensure that there's no bias and why are you using non-probability samples. So in your limitations, you could tell us, or in the methodology, you would explain why you choose this specific method of sampling. Look at literature review. What are other studies using? Are they using similar sample size? Are they using bigger sample sizes, less sample size? If it's been done and it's published and it's been accepted, what value are you going to add to the literature out there if you're going to do the same sample size and do the same sample? People won't publish it. Journals won't publish it because it's already done. It's already published. It's already proven. If you say that previous studies only did 10 people, now I'm doing 100 people, that's a different story because now you've looked at the sampling, you've looked at the literature, and you've modified it. That's fine. So when you're doing a literature review, also look at the sampling method they used. Look at the method they used in terms of the study design. Use those in your research protocol. Don't invent the wheel again. The wheel is there. Just use the baseline or evidence that is already out there. That's why a literature review is very, very important. If you do a comprehensive literature review, you will find the gaps and you could use the existing articles or questionnaires in your paper. And between us, if you ask any author, any author that is published in an international journal to share their questionnaire with you, chances are they will share it willingly because you are going to cite them when you publish your paper. And that's what academics want. They want citations and they want publication. So no one's going to be holding onto the questionnaire. Those days of holding onto the data are long gone. Even journals will ask you, you need to be able to share the raw data with them so that they can double check and make sure the data is all up to scratch. Sample size, we spoke about that. Qualitative studies, make sure that you got between 6 and 8 in each focus group, not too many because then it tends to cloud the questioning, not too little because patients are then scared maybe to discuss. Your inclusion or eligibility criteria. What criteria did you use to select your sample? Must it be all kids? Must it be all adults? Must it be kids that all have orthodontic treatment? Must it be kids that have never seen a dentist before, or must it be a kid that has seen a dentist before? You cannot choose a sample from a hospital and say that there is the prevalence of a condition because the hospital is sick people come, right? So all the people that come, they are already sick, they already have disease. So if you say you want to find the prevalence of a condition, then you need to go into the schools, into the creches, or you need to go out of the hospital. So again, this depends on your method and it depends on your objective. What do you want to achieve? Nutrition we spoke about, and your method, like I said in the beginning, it's like your engine. It's driving your research. You need to describe your method in detail so that if anybody else wants to carry out this study, it must be clear. They must be able to have access to be able to carry out their study without questions being asked. So you need to be clear. And often protocols are sent back to students because they will say, we don't understand this, or add more details here, or complete this more comprehensively because there are gaps that we are not we're not completing. Okay, sample size calculator. There are many on the market. I'm not advertising for any one of them, but you with your supervisor, you can choose one. We in South Africa, we use Rausoft often, we use Qualtrics. But again, we do not prescribe to our student. It depends on the level of the student. If it's a PhD, then they work with a statistician, that's fine. If it's a master's or if it's an undergrad student, we assist them and we will do the sample size calculation. But what I try to show here, and I think it might be a bit overcrowded, but if I look at all of these, they all will give me the same answer. I all need a sample size of 278, 278, 278, 278. And I use the population size of 1,000 or the proportional. So if you know your prevalence of disease, if you know or you expect or you know roughly how many people will respond, with your supervisor, you can punch in these details and the sample size calculated will give you the answers. They have a formula which is tried and tested, and there's no need for you to go over that. I'm not sure what level you are at, but we would not allow our master students to go over the formulas. It's already here. They will use these software calculators and they will calculate the size. And then you need to be clear as to how you calculate it. So in your method, you will tell us exactly which sample you used, and which calculator you used, and how you actually got the answers. Chair, should I stop now, or do you want me to just touch on descriptive statistics? I don't think I'll do justice to descriptive statistics. If you want, I could stop here. Or would you like me to continue with statistics? I've got 2, 3, let's see, 3 more slides. Is anybody there?
Doctor, I'm just waiting to see like the answers from the
Okay,
attendees. Is it okay, guys, for it like to be a little bit longer?
just a
Would that be
quick
fine with
snapshot.
most of you? Yes.
Okay, so I'm going to
They're
go
saying yes,
very
please
fast. Yeah,
continue.
I'm going to go very fast. And like I said from the beginning, I'm not going to do justice to statistics, and I'm sorry, but just an overview. So when you sit with your supervisor, you can decide clearly what statistics exactly you want to carry out. So there's two types of statistics. You get your simple and you get your basics and inferential statistics. Simple basic statistics, we look at mean, we look at median, we look at mode. What is statistics? Statistics is basically collecting your data, analyzing your data, putting it into categories, putting it into tables, putting it into graphs, and describing it. So that's what we do. So you could either use the proportion, you could use the ratio, you could use the percentage. It depends what you want. If you want an incidence or you want a prevalence, you want new cases, you want old cases, all of these then will depend on the type of statistics you are going to do. When you're thinking of your objective, you need to think also about the statistic that you will carry out. What type of statistics would I need to carry out in order for me to achieve my objectives? So that when you are planning your questionnaire, when you are planning your sample size, you know roughly what I need to do. Otherwise, you're going to go through the entire process. And at the end of the day, when you time to present or when you time to submit to the examiner, they're going to send it back and say your sample size does not represent the population or your sample size is too small. Okay. So central tendency, we use the mean, median, and mode. Mean is the average. I'm sure you guys know this. Median is you put it from highest to lowest, and then the one is in the middle is your median. Mode is the most frequent. In an ideal world, you'd want the mean, the median, and the mode to be very, very similar. Very, very similar, which means that your data is very tight together, which means there are not many outliers, many people on the site. Any of your data is close to each other. Okay, so how do we measure this? We use our standard deviation, we use the range, and we use this. Okay, so this is just an example. So say, for example, you've got test marks in 22, in 23, and 24 for dental students. N is the number of students that wrote the exam in every year. The range is from the highest to the minimum. You can see the minimum to the maximum. The range is in between your mean and your standard deviation. So if you look at the mean, for the first one is 65, then 54, and then the last one is 50. But if you look at the standard deviation, 16, 17, and 23. So the 23.28 is very large compared to the other two, which means that you have more variation in the marks compared to when you have it in 22 and 23. It's a measure of the widespreadness of the marks. Like I said, we need to discuss this in more detail. So I'm just giving you a very quick snapshot. This is a bell-shaped curve, and often we talk about parametric and non-parametric data. Again, it's complicated. I know I might be speaking to those who are already converted. Many of you might know a lot more stats than I do, but I'm not sure where we are. So I'm just telling you, this is where you would expect your data to be. So for example, if I want to look at heights or the height or the weight of all the dental students, I would expect it to resemble this bell-shaped curve where the majority of the people are in the mean and one standard deviation on either side. And you get your outliers, very old, very young, very obese, very underweight on the extremes. But the general mass of your population will follow this bell-shaped curve that it's called. And this is called parametric data, where it is symmetrical and you can run your parametrical tests. Whereas non-parametric, you have different types of tests. Parametric, you have different types of tests. Okay, finally, in conclusion, let's start again. Do not start with your sample size. Do not start with your study design. Do not start with your ethics. First, identify what you want to do. Identify how you're going to do it and what do you want to achieve. From there, once you've got that clear, then you can work on your study design. Your supervisor will then assist you to tell you what is the best way to get the study achieved, what would be the best way to get your aims. Sampling will then come after your study design. Once you know what study design you need, then you can decide on the sampling number that you need as well. So it's all interdependent. It doesn't work in isolation. And it all works together to provide a very robust article at the end of the day. If one of them is missing, for example, that email comes to your email inbox, you can't change it. It's not like a literature review or a discussion where they tell you to update your literature review or look at this article and include it into your discussion. They're telling you now your sample size is too small. You can't go back into the community and collect data. It's gone. The data is going to sit somewhere on a shelf because you did not do due diligence from the beginning. So always, always, always make sure that you do the research protocol with the end in mind. What do you want to achieve? Will I be able to achieve it? And make sure that you tick all the boxes. Okay. So that we said use a sampling methodology and framework. Consider the time of the study, the cost of the study, the prevalence of the disease that you are going to look at. These will impact on your sample size. would you have enough resources to circumvent these initiatives or circumvent these limitations? Okay. And the study, obviously, it's not something that you're going to put into a drawer and keep it there. You want it to be used. You want it to be practiced. You want it to make an impact. You want it to change people's lives. So your research, when you choose something that you know is practical, that has community engagement, that will involve the community, that will involve with your students, your academics, your staff. Community, not only community living out there. Your community could be your colleagues, it could be your student. So ensure that it engages all of the different strata or different categories so that your research can be robust and fruitful and make a difference to people's lives at the end of the day. And thank you very much. That's it. The questions.
Thanks a million, Dr. Ahmed, for this very insightful and informative lecture. The time for questions is open now, guys. If you have any questions, please either raise your hand or write it in the chat box. Dr. Menenegi says, thank you for the informative lecture. I believe it will be very helpful if we have a session to be trained on sample size calculations.
Okay. Like I said, we maybe different countries use different techniques. In South Africa, we don't spend much time on the actual calculation process or the formulas. We spend more time on the actual methodology, and we use the calculators that are available. But we can sit with AFRONE and we can arrange for something, and yeah, that's not a problem. It's doable.
All right, guys, any more questions? Dr. Maha says, thanks a lot for the great presentation. Dr. Latifa says, great presentation, doctor. Do we have any more questions? Dr. Moreniki says, great presentation. We had no problem with the accent.
Oh, thank you. Thank you. No questions. It could be a good thing or a bad thing. Let's hope it's a good thing and not a bad thing, because either no one understood what I said or it was too simple and everybody understood everything. So there's no need to ask questions.
No, I think they all like understood. It was smooth and it was to the point. It was really nice, doctor. Thanks a lot. Very good thing. Dr. Murani says, this is a good thing. You simplified it.
You're welcome.
All right, guys, if this is the end of your questions, if no one else has any more questions, then I think this concludes today's meeting. Please stay on while I just put the link for the evaluation in the chat. Give me one moment, please. Okay, we have one question. Dr. Latifa says you may include workshops in the program. Dr. Ahmed says, thank you very much, sir, for the information. As an undergraduate, where can one start like resources or platforms to do better informed sampling and statistical consideration?
For me, I think the best place would be to have a good mentor or a good supervisor, because it depends a lot on the type of study you want to do. And it's not an easy answer to say there's one resource or there's one textbook. You need to go through it as an undergrad student. There's a lot of information out there, and someone needs to just help you sift what is important, what is not important. So I would suggest that you work with someone who has got a lot of experience, or someone who is a good mentor and a good researcher. They'll be able to guide you. Uh, I'm proud to say that in this room and in the continent, we have really heavyweight in terms of research. It's just that we may be underrepresented in the rest of the world, as you saw from the other slide, when Prof. Maha presented on the publication output. But we have more than enough capabilities around this office, around this platform. So use the people that you have. I'm sure at your university, at your institution as well, you have researchers of note. So it's a matter of using the resources that we have rather than going and looking for resources that are often time consuming. As an undergraduate, you don't have the luxury of time to go all there and look. Whereas if someone can assist you, it makes your life so much easier. And like I said, there's a wealth of researchers out there. Just knock on our door and we'll be more than willing to assist you with whatever information we can provide. Thanks.
Thanks a lot, Doctor. Dr. Maha is asking, in view of the importance of sample size and the cost of sampling, how can we ensure adequate number of participants by collaborating in multi-country studies?
So multi-study collaborations have a role, but they also have a disadvantage because each country then needs to meet a minimum sample size depending on the prevalence or the condition that we are examining. So yes, it might look like you have a huge sample size, but if you have 10 countries, each country needs to come to the party with their minimum sample size. So we are working, Prof. Maha and I and other colleagues as well, are working on multi-country studies. But we need to then do each country will then have a principal investigator who is in charge of that country's data, and they will have to calculate the sample size based on their disease burden or based on their protocols that they have in their country. And based on that, then they would contribute to the multi-country study. Also for publications, multi-country studies are doing a lot better now because it's more generalizable. You could represent an entire continent rather than one specific part of one specific country. So a lot of us are going now for multi-country studies, but we need to have principal investigators in each area that can identify and collect the data responsibly and professionally. Otherwise, it takes the entire the thrust of that paper away, because then it becomes very weak and we cannot use it for comparison purposes. So yeah, I hope that answers Prof. Maha.
All right, great. Thanks a lot, Dr. Ahmed, for today. And thanks a lot, guys, for attending. Um, I sent the link for the evaluation in the chat, and I will send it again on the WhatsApp group. Please take a minute to give us your valuable. Hello, can anyone hear me?
Yeah, I can hear you.
Yes.
I'm the only one that can
That
respond. The rest are muted. So yeah, I'm sure they can all hear me if
yeah,
I can hear you.
they can respond in the chat as well. But yeah, always good. Thanks a lot, guys. Have a great evening, and I will see you in our next webinar. Hopefully, have a great evening, everyone.